Hi, and welcome to the Geo Show. This week on the Geo Show, we're going to be talking about Earth's interior. But first, I'd like to thank my Patreon supporters, especially A Friendly Doggo and Tyler Supreme Robinson. You can join them by going to www.patreon.com/feegs and sign up for our gold tier to get a shout out on the show, if you'd like. Also, we're offering merch now, and you can get this sweet coffee cup if you sign up for the Corundum tier support and stay signed up for 3 months. Imagine drinking a hot cup of joe out of this sweet thing. And now, on to our show. Understanding Earth through seismology. Seismic waves that travel through Earth are either P waves, compression or push waves, or S waves, or shear waves. P waves are faster than S waves, and only P waves can pass through fluids. By studying seismic waves, we can discover the nature and temperature characteristics of various parts of the Earth's interior. It is because these properties, we know the Earth's interior to look like this, with a solid crust, a lithosphere, a stenosphere, a solid but plastic upper and lower mantle, a liquid outer core, and a solid inner core. The crust and mantle are separated by a discontinuity in density called the MOHO, and is about 6 to 7 miles under oceanic crust and 24 to 30 miles under continental crust. The temperature of the Earth's interior. Earth's temperature increases with depth to around 5,000 degrees centigrade at the center, but there are significant variations in the rate of temperature increase. These variations are related to differences in composition and the existence of convection in the mantle and liquid part of the core. Earth's magnetic field. Because of the outer core convection, Earth has a magnetic field. The magnetic force directions are different at different latitudes. The polarity of the field is not constant and has flipped from normal, as it is now, to reversed and back to normal hundreds of times in the past. Isostasy. The plastic nature of the mantle, which allows for mantle convection, also determines the nature of the relationship between the crust and the mantle. The crust floats on the mantle in an isostatic relationship, like a boat on the water. Where the crust becomes thicker because of mountain building or accumulates glacial ice, it pushes farther down into the mantle. When glacial ice melts, the crust rebounds. Isostatic rebound is currently happening in the Michigan Basin. Oceanic crust, being heavier than continental crust, floats lower on the mantle. I hope you enjoyed my video. Please like and subscribe so you're staying updated on videos I release in the future. Don't forget to like us and follow us on Instagram. With that, I bid you adieu and cheers.